Hello and a warm welcome again to Basics of Remote Sensing and Geographic Information System. I am Vanessa Johnson and we are going to continue about Introduction to Remote Sensing in this video. We are going to be doing the development of remote sensing in India particularly. Then we're going to do the stages of remote sensing and the applications of remote sensing. This is quite an interesting video. Please pay attention. So the development of remote sensing or the historical background of remote sensing started with the foundation or the founding of ISRO and NASA. Not NASA, I'm sorry, NRSA. So ISRO stands for Indian Space Research Organization, and NRSA stands for National Remote Sensing Center or Agency. It was formerly known as Agency, now it is known as NRSC. Okay, now it is known as NRSC. So the first thing was that this was founded. Okay, it was founded in the year 1975, and these institutions played a pivotal role in advancing India's capabilities in space and technology and remote sensing. So I'm sure you all know about ISRO and what ISRO does, basically sending space rockets, satellites into space and finding out what is out there, right? And NRSC or NRSA, formerly known, also does take part in remote sensing. They work together hand in hand. Okay, the second thing that happened, ISRO was established in 1969 and NRSC was established in 1975. Sorry, I forgot to mention that. Okay, then what happened is that there was the launch of the IRS satellite. So IRS stands for Indian Remote Sensing. Indian Remote Sensing satellite was launched first in 1988, and after this there have been many satellites that have become integral to various applications, and these satellites are giving us a lot of information about the surface of the earth, especially giving us a lot of information about our own country. Okay, then the third step that happened was development of imaging sensors. So at that time our technology wasn't that great as it is today, so there has been a lot of development that has happened. So India has developed a range of imaging sensors including optical and microwave sensors. So if you do not know what is optical and microwave, do not worry, I have another video about electromagnetic spectrum in which I will be discussing what are microwave sensors and all of that in that video. Okay, so it has basically enhanced, the development has enhanced the capability of the satellites, and these sensors are now able to provide high resolution imagery and valuable data for a variety of applications. So we get a lot of variety of applications and we get a lot of data which is much better than it was before. Then we have had the launch of Cartosat series. So Cartosat, sat here means satellite. Okay, so it was launched in 2005, Cartosat series. These are high resolution earth observation satellites. These satellites constantly are observing the earth, and these satellites have been very instrumental in cartographic applications, thus the name Cartosat. So cartography is basically map making. So this series of satellites have been used for map making, urban planning and infrastructure development. So this is how the development of remote sensing has slowly started in India, and we'll look further. Then came the RESAT or the RISAT, however you want to say it. Okay, so RISAT, SAT again stands for satellite, and RI stands for radar imaging. Radar imaging satellites. This was launched in 2009. Okay, and it is just it basically employs synthetic aperture radar for all weather and day and night observation. So this is for agriculture monitoring. It is used for during monsoons, for the weather. It can be used either day and night. So these are very, very helpful for agriculture specifically. Then we have something called as the Bhuvan platform. So this is introduced by ISRO. This was introduced by ISRO in 2009, and it is a web-based geo portal. So even if you go after this video, you can just go on Google and you can just say Bhuvan, and you will get the website there. So Bhuvan allows users to access and explore satellite imagery and geospatial data. It promotes public awareness and enables various applications. So inside Bhuvan, once you log in, once you sign up for the data, you can find a lot of data that is freely available. You can find weather data, you can find out temperatures, you can find out rainfall, snowfall. You can even find out different satellite data from ISRO. Okay, so it's a very, very amazing platform. You should definitely check it out. Then we have integration with development programs. So what we started to do is that remote sensing, we started to integrate this into various national programs. So you must have heard of National Agriculture Insurance Scheme or the Mahatma Gandhi National Rural Employment Guarantee Act. There have been different watershed management activities also. There have been a lot of planning, development and planning for different cities as well. So we started integrating our knowledge of remote sensing and all our material available so that we can develop our country better. So this also was happening, and now we have come to international collaboration. So international collaboration, India is actively collaborating with international agencies in the field of remote sensing. It shares its expertise and data with neighboring countries and participates in global initiatives related to Earth observation. So India has different collaborations with different countries on different missions. So you can simply go on ISRO website and you can find out a lot more information about that over there. Okay, now this is a very, very important topic, which is the stages of remote sensing. Now how is remote sensing happening? I explained to you that remote sensing is basically gathering information about a particular thing without touching it, without direct physical contact, right? So how is it happening is explained here very well. So the first thing we need to remember that remote sensing can be done of two types, right? It is either active or passive. Now if you remember from what I spoke to you about, passive remote sensing is where the sensor or the satellite has no energy source, where it is using the sun as its energy source. Whereas active remote sensing is where the satellite or the sensor has its own energy source. This one has energy of its own, this one has no energy of its own. Okay, so in the stages of remote sensing, you can see that first there has to be a energy source of illumination. There needs to be some energy source for the sensor to be able to view the object, right? So if it is passive remote sensing, the energy source is the sun. then the sun's rays are going through the atmosphere and the radiation. So you must remember that these satellites and these sensors are high up into space. In space, it is orbiting Earth, but it is pretty high up, and because of its distance from the Earth, there's a lot of cloud, dust, particles of water, some chemicals also that are found in the atmosphere, and the because of this, it has to go through the radiation and atmosphere. Okay, then after that it goes and it touches or it reaches the target, whatever is your target out here. It can be a tree, it can be a field, it can be an entire area, whatever the target may be. After it reaches the target, it reflects back. So this goes up here, right, and it is recorded by the sensor. Now this example that I gave is for passive remote sensing, where the energy source is the sun. But if it is active remote sensing, the sensor will have its own energy source. So what does the sensor do? It sends the energy, or sends the radiation down, sends the electromagnetic spectrum. We will speak about that later, but it sends it down, right? It goes through the atmosphere and radiation, then it comes down and it has an interaction with the target, and then it goes back up again to the sensor, where it has recorded the energy. So we saw the energy source of illumination, then we saw radiation and the atmosphere, then we saw interaction with the target, and then we saw recording of energy by the sensor. Now once the sensor has recorded the energy, it sends it down to us. By us I mean to ISRO or to the NRSC. Okay, so when it does that, there is something called as transmission, reception and processing. So when ISRO or when the NRSC get this information from the satellite or the sensor, this information can be, some parts of it can be missing, some parts can be redundant. That means it can be repeated multiple times. So if it is repeated multiple times, the most of them have no value, or because they are repeating, they are called redundant. So all of that has to be processed, right? So that gets processed by ISRO or by NASA or by NRSC or whoever it is, and then it goes to the analysts, right? So the analysts are people who are working on these images. They are doing the interpretation and the analysis. They are seeing what is on the surface of the earth, what exactly was the thing that was noticed or what was seen by the sensor, and after that we have the application. So basically we can use this data for a lot of research. We can use remote sensing GIS data for planning, for multiple things. We'll look at the applications of remote sensing in just a bit, but this is the stages of remote sensing. This is a very, very important diagram, especially when asked in the exam. You must draw the diagram and you must neatly label it the way that it is shown in this image. So you can go back a little bit if you want, and you can take a screenshot of this image and you can try to draw it on your own. If you have any questions, any inquiries, you can comment down below and I will respond to you. Okay, now moving on towards the applications of remote sensing. There are multiple applications of remote sensing. It is used in environmental monitoring. You must have seen the before and after pictures, maybe before and after a hurricane, after a flood, after a cyclone, after a tsunami. So all of that comes under environmental monitoring. Even disaster management is similar, where you can see before after pictures. You can see what is happening. Environmental monitoring, I can give you another example, is before a cyclone hits, you must have seen on the news that they are showing you the images of the cyclone, or they're showing you how fast it is going or in which direction it is going. So all of that comes under environmental monitoring. Agriculture, by with the help of remote sensing, we can find out, or we can see which trees or which plants are diseased and which ones are healthy without going to that region. So for example, if I have a huge farm which I cannot go to and see each and every single plant and ask the plant, are you okay, when I have multiple plants, so what I can simply do is take an image, or acquire an image from any reliable source, and I can use remote sensing and GIS to help me find out if my agriculture area, or if my farm or my plants are doing well. If they are diseased, I can find out. If they are healthy, I can find out. It is known in used in climate change studies as well. So you must have seen the before after pictures of the ice melting and the glaciers reducing, right, in Greenland, in Antarctica. So all of that is happening under climate change studies. In health and epidemiology, so in the first video we saw about cholera, the outbreak of cholera, and how Dr. John Snow had mapped out cholera. So in the same way, during COVID, also during coronavirus, a lot of maps were made to know exactly where there's a higher concentration of people who are infected with the virus, of places which are not infected, or whatever else it may be. In forestry, it helps us, so it helps the government majorly, because you cannot go and visit, or you cannot go and scout the forest every time for any illegal activities. So if you look at the satellite images, especially the temporal ones that are taken from time to time, those satellite images will give you a very good idea of what is going on in the forest. If there is any illegal activity, maybe by some timber, if there is some company or some people who are trying to steal timber from the forest, or any other illegal activity happening in the forest, can be known by remote sensing. And you can just go through the other applications as well. They are quite straightforward, but if you need any more help and information about this, again, the notes I will be providing to you online, and if you want them, I can just send me a message on the comments. Just comment down below and I will get back to you as soon as possible. So thank you again for a wonderful time, and thank you for listening to me. I hope you have understood what I have explained. If you have any questions, please feel free to ask and let me know. Thank you so much. See you in the next video.